This is just a video about the scrap mechanic logic gate simulator, which is a tool for being able to develop complex circuits in scrap mechanic and being able to step through them before you actually go into the game. I mean, sure enough, in the game you can develop some pretty interesting contraptions with logic gates that just combine together a set of switches and sensors and whatnot and output. But anytime you have like memory bits and things like that, it can often get kind of confusing and weird. And this allows you to kind of go tick by tick through what's going on. So to illustrate how this works, let's just start out by doing something boring here. I'm just creating a line of AND gates and connecting them. You create a new gate either by dragging something in here from the field, or there's a keyboard shortcut for each one of these things. I mean, you can see here the keyboard shortcut for AND gate is regular A and NAND gate is Shift A. To draw a connection between parts, you drag from one to the next, and if you screw up and you don't want to do it that way, it's just like scrap mechanic where you just redrag over things and that makes it work. So, and then to move a component around, you hold the shift key and drag it, and then so the simulator starts in the off position, and we can turn it on and say, oh yeah, we're going to send a signal going through here by this is an input. Again, the input represents anything like a switch or a button or a sensor or anything like that in the thing. So we turn it on and oh darn it, nothing seems to be happening. Oh right, it's because this is an AND gate. Well, we can fix it either by clicking on it and changing it to an OR here, or it could have been you can do it here too. So let's get it back to an OR gate, and we can watch this stuff flow through. One of the things about scrap mechanic and most games that offer some sort of thing like a logic gate is that they have a concept of a tick, and on every tick they evaluate every logic gate, and that's true, but they don't evaluate the whole circuit. That if we look, for instance, here, it's saying, well, last tick, this one was true, and that's indicated by this darker, you notice this is green and this is dark blue. The dark blue says, oh yeah, this is the state I was reading at the beginning, was the last tick state, and that's was true, and so therefore this thing is true. And similarly, this one said my last tick state was true, and it's true, and then this guy comes along, and if we advance it by one tick, we say, well, the last tick, this one was false, and now this one was true, now it's false, and so we can walk through. So that's pretty much the big deal. There are some other controls on here that you'll see. One is this, which simulates us reloading the game, and that puts everything back to what's called the save state. Now, you might think save state, oh yeah, that's when I exit the game. Obviously, it saves the state of everything, and when I reload the game, it all is restored to that state. And that would make a lot of sense, but it turns out in scrap mechanic it's not true. In a video I'll link in the description, I kind of show that in fact there are a number of events that scrap mechanic uses to trigger basically recording the value that's going to be used at save, and one of them is not exiting the game, and also one of them is not changing the value of a switch. So you can, for example, if you go into the game and do things exactly as I say here. If you place a switch down, you place a piston down, you place a block on the piston so that it works, you connect the switch to the piston, you adjust the piston so it extends fully, you turn on the switch, exit the game, and come back. When you come back, you'll find the piston retracting because the switch's save state was false. You can manipulate the save state in a lot of ways. One is to paint the switch, and so we have this paint gun here that does that, or you can rewire the switch. And again, when you do that, it saves it to the state that the item is currently in. And so if we say, oops, start our simulation running, we pause it, oops, how did I do that? Oh yeah, I left the thing on. Okay. Yeah. So if at this point we whip out our paint gun and paint this guy and this guy, oh, whoops, got it in the wrong order. And you have to select the object and then press the paint gun in order for it to stick. It fills in this block, which basically means that the save state of this logic gate is true. Now, if I did the same thing again and I paint this guy, nothing happens because the save state is false. If we advance one tick, and I click this guy whose save state continues to be true, and I paint it, it becomes false. And then when we reload, that one is there. And to emphasize the point, I'm going to stop, reload, and that's what it'll do in the game itself. So there are a number of moments that you'll have observed that the game does things like that. Like if you put something on a lift, you can do with this button, it wipes all of your memory bits. And if you take something off the lift, then it basically paints everything that was, it's as if you painted everything. It saves the state as it was at that time, so that when we reload it, it comes back to that point. This button again simulates what happens when you exit and come back to the game. So let's come up with a more interesting example of what you could do with this thing, because again, this isn't for simple little circuits like that. It's for complex ones. And so, if we were to just build up our old friend, the whoops, wrong direction. The RS flip-flop. Yeah, this is kind of more of a thing that it's designed for. And this is kind of a common state. When you build up a flip-flop, you can sometimes end up in this condition where it's all crazy like that. You certainly get it that way if you put it on the lift. So you can stop that by taking it off the lift. Right now, if we right after we take it off the lift, it's painted, or that is to say, its save state is set to this. And so if we reloaded the game right now, nothing would change. If we change the state of this flip-flop, and then we reload it, whoops, it's back to the state. So that happens. So I just painted this guy again so that it reloads to a more sane state. So one of the things that you might have noticed about logic gates is or SR flip-flops, is if you push the button really fast, you can get it into this broken state. And in fact, the magic number, it turns out, is 3 ticks that you have to hold it down. But why is that? Well, with this, we could learn. So I'm going to make a second gate over here, just to make it so that we can easily compare what's going on with one or the other. And so I can give myself some buttons and do that and do that. Okay, and now I want to get it into the same state. And why is this OR gate still on? I wonder if it... Yeah, I just pressed F5 to refresh it. I think it... There's a JavaScript bug there somewhere. But, oh, I know it's still on, doofus. It's because it's an OR gate. That doesn't work. Alright, change this to an OR. Change this to a NOR. Again, there's a context menu here, and it has a lot of fun buttons that we'll get more into in a minute here. But let's get ourselves back where we want it here, where we have this. So now we're in a position where we can do some serious debugging. And so what I want to do is reload it. The reload button also sets the tick counter to 0. Oops, we're still not in a happy state. We're not in a happy state because I forgot to set our set the load state. Okay, so there you go. Now take off the lift again. Just paints everything. I'm going to pause the simulator. And reload, and okay, now we're finally ready to do some debugging. Except that these guys are on. Let's, again, clear those and do that. So, so again, when I don't think I've mentioned this, but in order to turn these switches on and off, I am control clicking on them. There are also a variety of other ways to do it, including the context menu here, but control click is the quickest. So that's what I've been doing. So one of the other tricks that we can do with inputs is enable recording, so that we don't have to keep, anytime we're trying to reproduce an odd situation that happens because of inputs, we don't have to just keep clicking it. And so with this top one, I'm going to leave it on for the 4 clicks that are necessary. And for this bottom one, I'm going to turn it off after 1 click. And we can see we're stable with this, and we're not stable here. So how did that happen? So let's go back and reload and watch this 1 tick at a time. So we take it 1 tick, everything looks wonderful. And then we take it another tick, and things have changed. That this is on here, but not on there. And how is that going to come back to bite us? So we advance to the next frame, and now this one is on, because this one was off a second ago. And this one is on, and that's all good. But now, whereas this one is in a stable condition, where you can see that this OR gate is on because this one is here. But this NOR gate is about to become false because of the presence of the value from this gate. And basically the situation devolves from there. So what can we do about that? Well, the way that you do it is with a pulse extender, to make it so that it'll the tick will be longer, but let's try just with one AND gate. So this will make it so this OR gate will stay on one tick longer. Maybe that'll fix it. Let's look. Okay, so here we are again. We go here, and this OR gate is true because of the button that was pressed last tick. It's true again because of the pulse extender, and everything at this point looks wonderful. We advance to this tick, and now we have a different picture. But does that matter? We don't know. And we advance to this tick, and now, yeah, it turns out it did matter because this guy got this guy at the end got lit again. And remember, that was what our downfall was last time, and so we're in crazy town again. So when we extend our, whoops, wrong button. We extend our pulse by one more. I'm going to reload this, and we can just press play this time, hopefully. Yeah. So that's kind of an example of how you can use this thing to to debug a moderately complex problem in short time. There are, first off, over here there's this help text, and maybe after a while you don't need it. You can blow it down like that, and to get your screen back, or you can bring it back if you need it. There are there's documentation in here which tells you all those keyboard shortcuts that I've been using, and a few other details. One of the things is there are a number of samples. Like this is actually a fully debounced memory bit, and there are some other things here which you can read about. And if you want to keep a copy of anything you built, there are these links. This one, if you click it, it'll create a URL for you that you can come back to, and then there's a save button here. If you have one, the URL can get long, and really it's all of these data, these coordinates, all that other stuff crammed into that query string, and that can be too long, and you can't actually use it for much here. If you instead you can do this, and that creates a JSON file, and with that we can open it's JSON, so you can open it up in an editor and look at it if you're inclined to such things. Of course, then there's the opposite of that. We can go here and load up one of those files that it saved, so you could maybe manipulate it on the side if you want to. We also have timers. You can make now of any length. And another thing you might do is add a description. For instance, for your own notes, if you're sitting there going, I need to remember you can just add in a note like that, and that'll be there whenever you hover over it, so that you can remember what you're trying to accomplish. So anyway, that's about all the things that I can think of to talk about with this thing. Again, this is just something I've done as kind of a labor of love. It didn't have to make sense. You might find it useful, and I hope so. And if you find a way to, for instance, make this thing better, I'm always open to help with that. Here's the link to the source code right there, so that you can do that. You can go to GitHub and open issues, clone the repo, do whatever you want to do. So another thing that I'd be interested in would be if you have a sample that you want to share, just send me a blurb of text like this and one of those links to the finished product, and I can take the time to integrate it. Anyway, thanks for watching. I hope this was helpful. Have a good day.